So in our next section here for Layer 3 VPN, we're going to look at the IPv6 reachability. And again, up to this point, we should already have the peering infrastructure set up based on the previous requirement of section 2.6, where we had router 2 and XR2 as the route reflectors for VPN v4. The only difference that we need to do in the core is essentially activate the additional address family in order to support v6 across the core. So basically we have two different customer networks running IPv6. We have MPLS in the middle. The key is that the middle of the network running MPLS doesn't necessarily have to be IPv6 aware. Instead, what we're doing is we're going to take the IPv4 next hop that we're advertising into BGP. This is going to get a special encoding into the IPv6 next hop of the VPN v6 route that we're advertising. So essentially the only place that we need to run IPv6 routing is going to be just on the PE to CE routing link. Okay, so we have two different customer tables that we're trying to route between. So we have A site 1 that's trying to reach A site 2, and then we have B site 1 that's trying to reach B site 2. Okay, so first we're going to look at on between router 10 and router 2. We're using EIGRP routing for our IPv4. So again, similar to OSPF with EIGRP, we have two separate processes, one that's going to be for IPv4 routing, one that's going to be for IPv6 routing. Again, from a syntax point of view, you can put both of these under the same process config, but behind the scenes, it's going to be two separate control plane instances. There's one set of adjacencies for IPv4, and then a separate set of adjacencies for IPv6. Okay, so let's start on router 10. And let's look at the show run section router. Okay, right now we're just running regular EIGRP, okay, legacy autonomous system EIGRP as opposed to the named mode EIGRP. Now what I'm going to do is to take this legacy config, and I'm going to have the CLI automatically convert it into the new format, and then we can use this new format for IPv6 aware routing. Okay, otherwise the format that I have in here, we would have to have a separate process number that would be used for IPv6 routing. Okay, so we say we want EIGRP, under EIGRP, we want to EIGRP upgrade the CLI. Okay, so we'll say that this is our named instance. This will be converted from route EIGRP 10 to the named instance. Do we want to proceed? Yes. Okay, if we now look at the do show run section EIGRP, okay, it's basically just move this under the address family config. Okay, so now the difference is that we can go to router EIGRP, go to the named instance, and then we're going to run address family IPv6 unicast. Okay, the rest of the configuration for EIGRP, super simple. That's the only thing that's needed to turn it on all of the interfaces. So we don't need a network statement like we do for IPv4. If we simply look at the show EIGRP address family IPv6 interfaces, we should see that any link that has a v6 address is automatically going to be advertised into the EIGRP topology. So if we look at the show IPv6 interface brief, we have the loopback, and then we have the physical port that's going towards the provider. Okay, so it's that gig 2.210. And if we look at the show EIGRP address family IPv6 interfaces, we see both gig 2.210 and the loopback have EIGRP enabled. But again, when we look at the show run section EIGRP, the only thing that we're doing from a syntax point of view is just turning the address family on. Okay, now the opposite of this, if we wanted to turn EIGRP off, then we would go to the AF interface and then to selectively disable it. Okay, so let's say, for example, I don't want to advertise the loopback into EIGRP v6. We would go to the named instance. We would go to the AFI, and then the AF interface would be the loopback, and we would say shutdown. Okay, so if we show run section EIGRP, This is basically saying don't advertise the loopback into the EIGRP process. So again, if we look at the show EIGRP address family IPv6 IPv6 interfaces, now we should see that the loopback is not being advertised. Okay, this is different than it being a passive interface, where passive means you're redistributing it into the, well, not redistributing it, but you're advertising it into the topology, but you're not sending hellos out the interface. When we say the AF interface shutdown, this is like removing it from the network statement under the IPv4 process. Okay, so pretty simple config. Again, basically we just need to turn the address family on, and then it's going to automatically run it on all of the ports. Okay, so under, let's say, no AF interface loopback 0, show run section EIGRP. Okay, we're running both AFIs. Okay, so next let's enable logging, terminal monitor, and then we're going to go to the other end to router 2. Okay, we're basically going to do the same thing. So if we look at the show run section EIGRP, okay, we already have the named mode. Okay, the named mode is needed in this case because we're doing the VRF aware configuration. If this was just a global process, we could say router EIGRP1 and then use the network statement under there. Okay, but for the PE to CE routing on the PE side, we need to do it in this format. Okay, so next step is that we're going to turn IPv6 on. So router EIGRP, we have the name. Address family is going to be IPv6 unicast, still for the same VRF, still in the same autonomous system. Okay, notice almost immediately we have an EIGRP adjacency form there, because again, it's enabling it on all interfaces that are in that routing table that have IPv6 addresses on them. So from the PE router's point of view, if we show IPv6 route for the VRF, let's say show VRF, this is VRF-B, show IPv6 route VRF-B, we should see that we're learning that EIGRP prefix. Okay, same next steps that we would do into IPv4 routing, which is that we need to redistribute between the two processes. So we're learning the route in from the customer router. We're now going to take that route and generate a VPN v6 update about it. But again, key point being here is that if we look at the show BGP VPN v4 unicast all summary, we already have this peering infrastructure set up. The only thing we need to do is to activate VPN v6 in the core. Okay, so instead of show BGP VPN v4, we're going to show BGP VPN v6. Show BGP VPN v6 unicast all, that's going to show us all of the routes. Right now we can see that we're not advertising anything into the MPLS network. So next step again, redistribution. We're taking EIGRP v6, redistributing it into BGP VPN v6. So if we show run section BGP, okay, we're basically going to do the same thing that we did here for the v4 AFI, so router BGP 123, address family IPv6 VRF-B, and we're redistributing EIGRP 10. Okay, notice here that it's looking for the autonomous system number. It's not looking for the name of the process. So the name of the process is just like OSPF. It's some locally significant variable. Under the address family, that's where we're specifying what autonomous system that topology is actually running. Okay, so redistribute EIGRP 10. If we then show BGP VPN v6 unicast all, we see we're now advertising router 10's loopback. Okay, next thing, we're going to do a BGP peering between router 8 and XR1. Okay, now for this portion, when we're using BGP as the PE to CE routing protocol, and we're doing dual stack routing, so we're routing both IPv4 and IPv6, from a design point of view, we now have the decision, how many BGP control plane sessions do we want to maintain between the provider edge and the customer edge? Okay, and I want to kind of write this out in a table here because the variations can get kind of confusing. Okay, the difference is going to be what is the BGP transport versus what is the actual address family identifier that we're advertising the network layer reachability information about. So basically like the application data that we're advertising into BGP. Okay, so BGP can be using IPv4 for transport to advertise IPv4 routes. We can use IPv4 transport to advertise IPv6 routes. We could use IPv6 transport to advertise IPv6 routes. But we could also use IPv6 transport in order to advertise IPv4 routes. Because again, with BGP, you want to think of this not necessarily like a routing protocol, but more like an application where the goal of the application is to advertise the reachability information. In order to actually route packets to it, that's still going to be based on your underlying IGP, your underlying label switch path. Okay, so ultimately, again, the BGP next hop value that we're advertising into the core, that's going to determine where the MPLS label switch path is going to. Now, which of these variations that we're doing here in terms of the peering would really depend on the question. Okay, does the question say that we can establish multiple BGP peers, or does it say something like use the minimum number of statements? Okay, so what I'm going to do first to start is we're going to do an IPv6 peering that is advertising IPv6 information. Okay, we already have an IPv4 peering that's advertising IPv4 information, so we're going to add another separate control plane peering. Okay, so we're first going to start on the customer router, okay, on router 8. Okay, so on 8, let's look at the show IPv6 interface brief. We have our loopback, and then we have the two physical interfaces that are going towards the BGP peers. Okay, so we're going to be peering to 2001 10:8:11, and then XR1's address is 11 on the end there. Okay, if we look at the show run section BGP, we're already peering to them with regular IPv4. Okay, so next under BGP 8, we're going to peer to 2001. So you do show IPv6 interface brief. Okay, 2001 10:8:11, and they are in remote AS 123. Create the peer group first. I have one extra colon. That should be 2001:10. There we go. Okay, if we do show run section BGP, and we look at the show, actually this we have to establish the neighbor on the other side. Let's go back, let's go to the other side here on XR1. And we're now going to do the same thing. So let's say show run router BGP. Okay, and this is going to be inside of the VRF. So under BGP 123, we're inside VRFB. We need to turn address family IPv6 unicast on. Okay, then we have our neighbor, 2001 10:8:11:8. It's remote, AS is 8. Okay, since this is an eBGP peer, if we look at the config, we have to make sure that we have a route policy applied both outbound and inbound. Okay, again, if we were to forget this and then we look at the show BGP summary later, it's going to have the exclamation mark telling us that we're not receiving updates, we're not advertising updates to that peer. So if we show RPL, do show RPL, we already have a route policy passed that just says to allow everything. Okay, so we're under BGP, under the VRF, under the neighbor, address family is going to be IPv6 unicast. Okay, we have the route policy, pass is applied outbound, pass applied inbound. Okay, so up to this point, the only thing we're doing is just peering IPv6 with them. Okay, next let's go back to the customer router, and let's look at the show BGP IPv6, show BGP neighbors, show BGP, let's see, show BGP IPv6 unicast, neighbors, show BGP IPv6 unicast summary. Okay, let's check this from the XR side. Show BGP neighbors. And we're looking for show BGP VRF B neighbors. There we go. Okay, so BGP neighbor is this particular IPv6 address, and then we want to know what are the address families that we've negotiated with the peer, or what does the capabilities exchange say? Okay, the capabilities exchange is going to tell us what type of routes can we advertise to the neighbor. Okay, so we're trying to negotiate address family IPv6 unicast with them. And right now, connection established is 0. Okay, the issue here is that from the iOS's box point of view, even though we have this specified as an IPv6 neighbor, the default behavior of BGP is that we're activating only the IPv4 unicast AFI. So by doing this neighbor statement pointing to an IPv6 address, what the process is actually trying to do by default is this fourth option where we're using IPv6 for transport, but once the BGP session is established, we're going to be using it to advertise IPv4 routes. This is the reason that when we look at the show BGP IPv6 unicast summary, it doesn't actually show anything on router 8, because even though it's an IPv6 address, that guy's configured as an IPv4 peer. Okay, so it's kind of, or excuse me, it's not configured as an IPv4 peer, but it's advertising that that address family. And also, do I have the interface shut down? That's going to make a big difference too. Show IP interface brief, which I do. I do have the interface shut down. Thank you. Okay, so the v4 neighbor is up, but notice that from a v6 point of view, still same behavior. Okay, we don't see the summary of the neighbors. If we show BGP IPv4 unicast summary, we do see the v4 neighbors, but we don't see the v6. Okay, also, what may not be on by default is IPv6 routing. Okay, in regular iOS, normally regular IPv4 routing is on, but IPv6 routing can be disabled. Okay, so make sure in global config we say IPv6 unicast routing. Okay, but again, essentially the issue is that I've told it to establish the peer, but I didn't tell it that we actually want to run that particular address family. So what we're going to do here is under address family IPv4, we're going to activate the IPv4 address and deactivate the v6 address. Then under the IPv6 address family, do the opposite. We're going to activate the IPv6 peer, and we're going to deactivate the IPv4 peer. So it'll be two separate control plane sessions, one for v4, one just for v6. Okay, so we're going to say under address family IPv4 unicast, neighbor 10.8.9.9 is activated. Neighbor 10.8.11.11 is activated, but this neighbor is not activated. Okay, then vice versa, under address family IPv6 unicast, we're not activating the v4 neighbors, where the v4 addresses, I should say, no neighbor 10.8.9.9, activate, and we are going to activate the v6 neighbor. Okay, if we now show run section BGP, okay, basically means to these two peers, we're going to advertise v4 information. To this peer, we're going to advertise v6 information. Okay, now we can see that the neighbor changes state to up. So kind of a strange behavior because you're assuming that you're using an IPv6 address, that's the data that you would be advertising. But the key point is that BGP has that separation between what's the protocol used for the transport versus what data are you actually advertising. So you can combine them both together, but we'll see that there's going to be an additional step in the config that we would need to maintain there. Okay, so now we should be able to look at the show BGP IPv6 unicast summary, and we see the peer. Okay, if we show BGP IPv6 unicast, right now router 8 is not advertising, so it's not advertising anything. So let's go under the BGP process. We're going to go to router BGP 8, address family IPv6, and I'm just going to say redistribute connected. Okay, then show BGP IPv6 unicast. Okay, we're now advertising our loopback 2001::8. Okay, next step is that from the provider router point of view, we should be receiving the BGP IPv6 update from router 8. We're then going to turn this into a VPN v6 update. Okay, so we're going to export it out to the BGP table. Okay, from XR1's point of view, if we look at the show run VRF, we need to make sure that that address family is activated under the VRF. Okay, so notice here that under BGP, it did allow us to put the peer. Okay, so under VRFB, we have address family IPv6 unicast. But when we look at the show VRF, or show VRF detail, show VRF all detail, that address family IPv6 unicast doesn't have an import or export policy, okay, because it's not activated. Where in regular iOS, it argues with you, it gives you an error message that when you go to attach the VRF to the interface, if there's an IPv6 address on there, but the VRF doesn't have v6 enabled, it tells you. Okay, in XR, for whatever reason in this version, there's not an error check for it. So if we show run VRF, we first need to activate that AFI. Okay, let me make sure that's the right interface. Show IP interface brief. Port 811 is VRFB. Okay, so under VRFB, we have address family IPv6. Unicast, we're going to do the same import and export route target policy. Okay, next let's look at the peering. So we're going to show BGP VPN v6 unicast summary. Okay, we're peering to the reflectors and we see that we're learning one route. Okay, that one route should be the one that's coming from router 10 on the other side. We redistributed EHRP into the BGP process. So if we show BGP VPN v6 unicast, okay, we now have our route that's coming in from BGP from the customer. Again, when we're running BGP to the customer edge, we don't need to redistribute BGP into BGP. It's automatically moving from IPv6 unicast into VPN v6. Now, the key point here is that when we look at the final VPN v6 table, the next hop value is pointing towards their IPv4 loopback as opposed to IPv6. So what this means from XR1's point of view, in order to route down to router 10, what it's saying is that we need to label switch packets to 2222. Now, assuming that we already have our IGP plus LDP set up in the core, that we already have those LSPs running, the only thing we essentially need to do is just activate VPN v6 in the core, do the peering between the PE to CE router, and then the traffic in the middle of the network is going to be all MPLS label switched. Okay, and again, the way we verify the core is just going to be to trace to the BGP next hop, sourcing it from our BGP next hop. And we should see that this is following a label switch path. Okay, in this case, it doesn't really show because these guys are directly connected. But if we show MPLS interfaces, we should see that this interface is running LDP. Okay, so next let's look at this from the final customer point of view. On router 8, if we look at the show IPv6 route, okay, we have the route to the other end, 2001::10. We go to ping the destination, source from 2001::8. Okay, can't reach it yet. Let's see, does 10 have a route back to us? Okay, because remember, routing is a bidirectional process. Just because I have a route to you doesn't necessarily mean that you have the return route back to me. Okay, so let's go to router 10 and look at the show IPv6 route. Okay, in this case, we do not have the return prefix. Okay, let's go to the provider edge, which in this case is router 2. Let's make sure that router 2 is actually advertising that. Okay, so if we show run section EIGRP, we need to redistribute BGP into the EIGRP process. So basically, same thing that we're doing here. We just need to copy and paste this down to address family IPv6. Okay, under address family IPv6, topology base, redistribute BGP. Okay, and again, note that we need to set the seed metric here simply because the other site is not running EIGRP. If it was EIGRP to EIGRP, then the composite metrics automatically get encoded as BGP extended communities. Then you don't need to set that seed metric. Okay, now from router 10, we should see those EIGRP external routes, which we do. Okay, so final verification, we're trying to go from 8 to 10. Okay, the key is that in the transport in the middle, when we go to trace the destination, we should be following the MPLS label switch path towards the IPv4 loopback. Okay, so let me change some of these interfaces in the middle to make this a little bit more obvious. So let's go back to XR2. I think I had some of those ports shut down from before. Show IP interface brief. Okay, these interfaces here. Actually, what I probably can do, let's say, show config commit changes since your last one commit. Last two commits, those. Okay, so I'm going to unshut these 4 ports. Okay, then from router 2's point of view, I'm going to disable the interfaces that are going towards ISIS, these 3. Okay, the point being is just I want to see a couple additional hops as we're going this way so we can see what the full MPLS label switch path is. So from router 2, I'm going to disable ports gig 2.12, 211, okay, that's going to XR1, and then 212, which is going to XR2. Okay, now since we have the multiple points of redistribution, again, remember one of the requirements previously was that if any of the links are down, or at least one of the links is down, we're able to reroute the traffic. Okay, so we should still be able to maintain the BGP peering because we have those multiple IGP paths. So from router 2, if we ping to 11, 11, 11, 11, source 2222, okay, we can still reach it. If we do a trace route, we should see this is following a label switch path. Okay, now from router 8's point of view, we do a trace route to 10. Okay, this here should be XR1 still converging the IGP because I shut those interfaces down. Okay, there we go. And let's try this. Let's try sourcing this from the loopback. I think we need to do an extended trace route. Trace target address 2001::10. Trace IPv6. Okay, target address 2001::10. Source address 2001::8. Okay, so notice here in the middle, like router 3, for example, we're still able to reply to the trace route even though that box is not running IPv6. Okay, reason why is that the trace is encoded as an IPv4 response back. But again, the key is that we're using the label switch path in order to get to the IPv4 loopback as opposed to the IPv6 loopback. Okay, so if you guys have any other specific questions on the IPv6, let me know. We're going to come back to this in more detail as we go through the next section with the carrier supporting carrier, and then also when we come back to troubleshooting. But really, the key point about this is mainly the PE to CE routing, and then simply to activate VPN v6 address family in the core. So as long as our label switch path is already set up using LDP, using traffic engineering, BGP, whatever, so we trace route between the loopbacks, we find it's using a label switch path, then we can simply advertise IPv6 to the customer, take their routes, advertise them as VPN v6 in the core, and then write on top of the IPv4 labels in order to get to the v6 destinations.